So hi everyone, welcome to my YouTube channel. So today my video topic is deployment of our base model onto the local server. So in this case study, if you remember, we work on the data pre-processing and then feature engineering, then feature selection, then model selection, model evaluation, and we also explain the model predictions on the global level with the shap and on the local level with the line. But as if we work on the industry, then we need to after all processes we need to deploy like our solution to the productions, because if we can't deploy our solution on the production, then what is the use of those models, what is the use of those whole efforts. So here firstly we deploy this model onto the local server, and in next video we will deploy this same model onto the cloud. And here we are using the AWS. So first we in this section, like our agenda is to make first training pipeline and prediction pipeline, so that we can use same pipeline on the predictions, same on the training, and then we deploy those pipeline onto the uh, local server by using the REST API, and here we are using the Flask API. So let me proceed. So here are the basic dependencies for these trainings and this pipeline. And here basically first we need a frameworks. So earlier you see like into the different phases we use the Jupyter notebooks, but here we need a framework. So here are the framework you see on my screen. This is the framework sentiment analysis, and this framework has multiple modules like the data loader, data pre-processing, evaluation, model, notebooks. So in notebook section, you can see these contain the codes related to our previous videos, like the data pre-processing, feature engineering, feature selection, EDA, model selection, model evaluation. So all code here you can directly, if you are interested, you can see all codes, all Jupyter notebook from here. And in the end, I will commit this all code into the my GitHub repository. Then you can directly download all the code and data. You can use this as per your requirement. So let me back to our main file. So in main file, you can see like first we are loading data and we are calling the data load. And this data load is the function under the data loader module. You can see here we have the data load and we create a function to load data. And also we are mapping this problem from the different rating problem to the binary classification. So this is the similar code we see in the Jupyter notebooks during our feature engineering. So once we load data here and then we are splitting this data, this is also like the same code as I explained during the feature engineering also. And now like the pipeline is coming to the picture. You can see here we are using the pipeline from the sklearn. And if you can see here, like in the sklearn pipeline, we are importing the pipeline. And here we are using three steps. One is in the data pre-processing. You remember during our video, so we do the cleaning of the data, removing special characters, URL, then stop word. And so these all steps we need to put together into the pipeline. So here basically we are creating a class of data cleaning, and then we call all of the functions in the data cleaning. So let me go to the data pre-processing. So you can see here in the data pre-processing, we have the codes related to our data pre-processing phase. In the data pre-processing video also, I explained this whole code. This include the stop word from the analytical library. Then we have the regex to clean the special character, then URL, then stop word, then the contractions. So this is the same code which I explained in the previous video, like in the pre-processing video. But here one things, we make the custom transformer here. Like we are creating a class is data cleaning, and then we are inheriting the base estimators and transformer. So you can see here, this is the format to create a custom transformer. Here, this is the requirement while we are using the sklearn pipeline. So this is the one change we do here. Then we are calling this data cleaning here in data cleaning pipeline. So you can see here in first step, we are cleaning the whole data. And let me show you one more thing. So as we are for the finding of the EDAs and the feature engineering, we are adding these few words into the stop word list to remove these words from our final pipeline. So Mario, blah, blah, Saturday, Monday, Sunday morning in Friday. These are the findings from our feature engineering, from our ED. So we are removing these things. So let me back to our pipeline. And in next phase, you can see like we are using the TFID vectorizer. So as per the finding of our feature importance and feature selection, we see like the TFIDF is working well if we compare with the count vectorizer. So that's why we are using the TFIDF. And then we are using our base models with the hyperparameter, which we find during our model selection. So let's move to the next. In the next section, you can see here. So this is the fit command, simple command as we used earlier into our modeling part also. So same command we are using here, and we are feeding the raw data, raw training data, and they are training labels to train our pipeline here. And then we are generating the prediction for unseen data. This is the text data which is not feeding during the training, and now we are generating the uh, prediction for that. And after the whole like the pipeline is ready, then we are again scan recheck here to check the evaluation of this pipeline on our test data, so that make sure like the accuracy is maintained, same accuracy we are delivering with the pipeline also. And in the end, after the training, we are saving our model into the our uh, repository. So you can see here in the models we have the folder name model, and in the model we are storing this trained model with pipeline. So you can see here we trained our model with generating the pipeline. So in the production we are loading same pipeline with the help of joblib, and then we communicate this model with the help of API. So let me move to those parts. So here in the sentiment analyzer engine PY file, we have the REST API here using the Flask. And you can see here we have the two things here. One is the home page, another one is the prediction page. So first we created this page into the HTMLs, then we create the endpoints like the API endpoints respectively. So let me show you these pages. So into the template format, yeah, this is the home page. In the home page, so you can see here in the home page we have the one input field on which user is providing their review, and then we have the submit button, and after clicking on the submit button, it's calling our prediction API. So here, and in the prediction API we have the prediction page here, and on the prediction page we are basically returning the label of the prediction and then the sentiment value. So let me show you on the browser also. So you can see here, this is the page. So you can see here like that this is a simple HTML page we generate for this case study. And if like if user provided a review here, then and once user click on the check sentiment button, then it's call our prediction API and then check the sentiment. So let me click here. So let me check the sentiment for the unseen data. So this is the data from one of the movie, and you can see here rating is 1. So sentiment should be negative. So let me check the sentiment and let me go back to the code. So first explain. So let me explain you the code here, how the API workflows work. So this is the code for the home page. So this is the home page. We are calling home page template here. And this is for the prediction page. And in the prediction page, you can see here, like we are consuming the data from the home page into the review once we submit the review. And then in the review further, we are calling the prediction function from here. And in the prediction function, we are loading the model from our repository. From here we are loading this model, and then we are generating the predictions. And if label is like the prediction level is 1, then we are returning the sentiment is positive. If prediction level is 2, sorry, is 0, then we are returning the negative sentiment, and in the end we are returning the label and the sentiment value. And let me back to our yeah. So here you can see here, let me back here into our prediction page. So so we use this sentiment and the rating is 1. So here also like our prediction level is 0 and the sentiment is negative. So as expected, you can see here our sentiment is negative and prediction level is 0. And let me back and let me check. So let me check the score and sentiment value for another review. So let me copy this one. And it will take few seconds because the API servers and all things is working on the same machine. So that's why it take time. And let's wait for 2 seconds. So you can see here like the our class level prediction level is 1 as an expectation because the it's reviews 10 out of 10 and the sentiment is positive. So that's how our API is working. So we are feeding data from here and then checking the sentiment on the prediction API as well. So let me back to our framework. Now we create the end-to-end pipeline for our base models. So you can see like like the user directly feed data through the web UI, and then those data go to our pipeline, and in the pipeline, then this pipeline calling that pre-processing functions, then vectorizer, then the base model. So all things into the pipeline. No change is required uh, from anyone end. So this is our goal. So in this case studies, we achieve like we do the pre-processing as I explained earlier. Also feature engineering, model selections, and evaluation for all phases is done. And after this, I will create a separate video on which we deploy same model to the AWS cloud. So thank you for watching this video, and please like and subscribe my channel if you still not subscribe my channel. And in case of any query, any concern, you can directly put comment in the below section. And regarding the code, as I explained earlier also, so I will commit this all code onto the GitHub repository, and you can directly download this code to the my GitHub repository, and I will provide the link into the below description of the video. So thank you.